Okay everybody, so this video is on solving absolute value inequalities. So the difference here is that these are inequalities. Inequalities, not equations. They have some similarities and they have some differences. So at the top we have equations. At the bottom here we have inequalities. Greater than, less than. Okay, in the case of the first equation, if you recall, the absolute value of x is equal to 5. Once you get these bars isolated and alone, you write two equations, x equals 5, x equals negative 5, and then you go on to solve. In this case it was fairly simple. You didn't have to do any extra steps. Two answers are 5 and negative 5. This one over here, the absolute value of x is equal to negative 5. You want to be careful with that. Immediately what you want to do is just stop, because you cannot have a negative absolute value. So in that case, there's going to be no solutions. So remember that. You get absolute value and you just get to the place where the bars are alone and you have a negative number. Just stop. Don't try to write two equations, because you can't have a negative distance. Right away, that's your free pass to no solutions. Down below, this is greater than. These are a little different. One hint that you're going to hear is the word greater. If you hear greater, it can be phrased as or. If you see less than, it's going to be thought of as and. So this is sort of similar to what you had in probability. Of course, it's totally different math. So you want to say to yourself, the absolute value of x is greater than 5. Well, what numbers are greater than 5? Just a second ago, we did the equation part of it, and it was equal to 5 and equal to negative 5. But if you think about it on a number line, you have a number line, and you've got 0 in the middle, you've got 5, and you've got negative 5. When something's absolute value is greater than 5, well, where are those things going to be? Well, they're not only going to be at 5, darken it in because it includes it, but it's greater than, so it's everything that's up this way. And what about the other stuff? Well, it's also going to be everything that is at negative 5 or less. So this is the situation that we called or, because your answers to this are that x is greater than 5 or x is less than negative 5, less than or equal to, greater than or equal to. So you have two different solution regions where the middle is not part of the answers. Conversely, when it says and, that winds up being the exact opposite. It winds up being this range in here. Your answers on this one will be, here's 5, here's negative 5. Your answers will be equal to 5, equal to negative 5, and everything that's between them. That might be written like x is less than 5, or equal to, or greater than, and greater than negative 5. Okay, very similar to the first page. You don't want to get caught in this situation where you have the negative 5, which could trip you up. This one simply says it is greater than 5, so you could simply put whatever is in the value bars here right in the middle. So that'd be one sentence, x is greater than 5. What else is true? X could be less than negative 5, and you'd graph those up just like we did earlier. Now in this one, once again, you got to be careful. The absolute value of x is going to be greater than negative 5. Well, wait a minute. All absolute values, what do we know about all absolute values? All absolute values must be what? They must be positive. So is any absolute value going to be more than negative 5? Yes. So what does that mean for solutions? Think about it. Okay, it means that all real numbers will be solutions. Okay, so just take a minute to make a note of this. If you're solving absolute value equations, you're going to have and problems. Their solution sets will look like this. You'll have or problems. Their solution sets will look like this. It's either below this number or above. Okay, these ones are the ones that are related to greater than. Okay, these ones are more than but less than another thing. If you had to write them out, this one here is going to be like x is going to be in the middle. It's less than, say, 10, but greater than, say, negative 10. This one over here might say, oh, x is greater than 10 or less than negative 10. Okay, so here's one for you to practice your skills on. Absolute value of x is decreased by 5 is less than 2. So you want to work to isolate the absolute value bar and then move forward to solve. Go ahead and do that. Pause right now. Okay, so here's what your solutions should look like. You want to get these bars alone. You add 5 to both sides. You get the absolute value of x is less than 7. This is less than, which is an and. All the absolute values are less than 7. That means that what's in here, its value must be less than 7. But the other thing that has absolute value less than 7 is anything inside of negative 7. When you go to graph those and show all your solutions, in the middle will be 0, out here will be 7, over here will be negative 7. It does not include 7, does not include negative 7, but it's everything in between. Okay, so this is question number 2 for you. Give this a shot. Go ahead and hit pause, solve, and show all possible solutions. Okay, so hopefully you saw what was going on here. You saw that you want to get these absolute values alone. It's plus 4 right here, so you take away 4 from both sides of the inequality to get this alone, and then you notice that we're looking for an absolute value that's going to have an absolute value that's going to be less than negative 1. Well, can you have an absolute value that's negative? No, the lowest absolute value you can have is 0. So this absolutely has no solutions at all. If the arrow had gone the other way, we can have any number that has an absolute value that's going to be greater than negative 1, because all absolute values are greater than negative 1. That would have any real numbers as a solution. This one, however, has no solutions. Okay, so this one has a couple layers to it. You have to make sure you use SADMAP. Go ahead, hit pause on the recording, find all your solutions, and graph all possible solutions. Okay, so here are the quick solutions on this. There are 2 layers. You've got to add 5, and you wind up with this simpler expression, but once again you're trying to get to where you have the bars alone. These bars are multiplied by 2. Do not try to distribute. You can't do that because there are 2 answers to this. So you just got to divide both sides by 2, and you wind up with the bars alone. That's what you've been waiting for. The bars are now alone. Their absolute value is less than 6. That means that what's in here is less than 6 away from 0. So it's going to be inside of 6. It's going to be less than 6. But it's also got to be above negative 6. So this right here is how you can do it in one step. And you want to find out what x is, so you're going to subtract 3 from all 3 sides. All 3 sides. Minus 3, minus 3, minus 3. Negative 6 minus 3, negative 9. X plus 3 minus 3 gives you your x. 6 minus 3 gives you 3. So x itself is going to lie between 3, including 3, and negative 9, including negative 9. You can check this by checking 0. 0 should make it true. 3 should be exactly equal. Negative 9 should be exactly equal. Try the 0. 0 plus 3 is 3. Absolute value of 3 is 3. 3 times 2 is 6. 6 minus 5 is 1. Is 1 less than 7? Yep, that checks. Check it out with 3. 3 plus 3 is 6. 2 times 3 is 2 times 6 is going to be 12. 12 minus the 5 is 7. That checks. Check it with negative 9. Negative 9 plus 3 is going to be negative 6. Absolute value of that is 6. 2 times 6, 12. Minus 5, boom, 7. Again, it checks, so you're good to go. Okay, so for your homework on this, we have 6 little problems. First one, basically just want you to show all possible solutions, graph your answers. Absolute value of x is greater than or equal to 2. This one is absolute value of x is less than 3. So those are very straightforward. Just make sure you review your notes on and or, and make sure you square away the stuff with the direction of the arrow and whether or not it equals. This layer here, there's a couple layers. You've got multiplication you have to undo, and again, you have multiplication that needs to be undone, but also you've got the 2 involved here. Remember, you're trying to get the absolute value bars alone. Then you write your compound inequality. These last ones are fairly simple. I just want you to make sure you have the graphing skills down. I want you to graph where x, show all values of x that are greater than negative 2 and less than 5. This one, show all values of x where x is greater than 5 or x is less than or equal to 3. Good luck.